Hello, I am the Programming Dunce, and in this video I intend to wrap up the Intro to C++ series. This will be a long, slide-based video, but without the desktop portion at the end. I intend to cover static variables, references, and bitwise manipulation. In my very first video, I mentioned that a program has a code section, data section, and a stack section. Erroneously, I implied that the stack section was seldom used in that section. I have made changes to that video. Whenever you declare a variable, that variable is pushed onto the stack. When you exit the if, while, for switch block, or the function returns, those variables declared in that block are popped off the stack, making that memory useful for future use. When you allocate memory, either through new or malloc, you are drawing from the heap, which is like the stack, but from the opposite end from your stack. Yes, your memory could get scattered in the heap. So, if most of our data is actually stored in the stack, when is data used? There are two occasions I'm aware of when the data program is used. One is when you use a value directly in your program. When you declare a character pointer of a specific string, or an int of a given value. That string value is baked into your program and thus found in data. Yes, your variable may still be in the stack, but it will get the value from the data. The other occasion data is used is with a variable with a static attribute. Static variables exist throughout the duration of your program. In C, you could use them in a function. In the example in the background, the static int stat is initialized to 0 and then incremented. The initialization to 0 only occurs the first time that function runs. The incrementation occurs each time the function runs. Thus, in this case, stat can be used to count how many times the function was called. In C++, you can have a static method or attribute in a given class. With a regular attribute, it is copied every time a new object is created. A regular method works with a specific object. A static attribute is a variable shared by each object of the class. A change made by one object will be reflected when another object attempts to use it. Likewise, a static method can't work with individual objects unless it is provided a pointer reference to one. I've used this setup before to ensure only one object ever comes into existence at a given time, making the constructor private and using the static method to return the one object. Now I'm going to talk about references. Recall back in video 6 when I demonstrated the use of pointers. When you pass a pointer, you just copy the pointer into the function method, not the whole object. However, this opens up potential security issues. The pointer passed can be null or it can be dangling, meaning pointing to garbage memory you're not allowed to use. While checking if a pointer is null is easy enough, you can't really check if it's dangling or not. However, you can pass by reference. In the function prototype implementation, add an ampersand to a given parameter type instead of a pointer star. When you call the function /method and in the implementation, you can treat it as if you have the whole object. The compiler will create an alias in the function for the external variable and copy the location of the object rather than the object itself. With references, you get the benefit of passing by pointer with reduced risk of getting a null or dangling location. The third topic I want to cover is bitwise manipulation. Every piece of data is represented in a computer in zeros and ones. Sometimes you might want to manipulate data bit by bit, such as when implementing an encryption algorithm. In C and C++, you can specify a value in terms of its bitwise representation. It is easiest to manipulate bits in an unsigned jar, the C++ data type that best represents raw bytes. You also have access to special bitwise operators. Bitwise AND, bitwise OR, and bitwise XOR are the main comparing operators. You have also seen the left shift operator in a previous video. The right shift operator has a similar effect to the left shift operator, but in the opposite direction. I figure it might be easier to show the effects of these operators in an image rather than explaining them. The final topic I want to cover is how to accept input parameters from the command line. Sometimes you might launch a program with multiple parameters. There is a way to process those parameters in your program. In our programs, our main function had no parameters. However, we can use a version of main that accepts two parameters, an integer and an array of C strings. Traditionally, the integer is called argc and the array is called argv. Argc is the number of arguments provided, which is at least one given that the first argument is the one that launched the program in the first place. You can then use the argc variable to see if you can access a certain location in the argv variable. As it happens, there is no version of main that supports C++ string or a vector. We are stuck with a blank main or a main with an integer and an array of C strings. This concludes my Intro to C++ series. I might cover future topics for C++ as an advanced topic in the future, but I'm also interested in other topics as well. Please subscribe so you can catch me when I talk about Rust, MFC, DirectX, OpenGL, and other topics that might catch my interest. Thank you for watching my boring series on C++ basics.